number one, we want to create a working directory. Now we have gone a little bit back. We said today we are going to work on three things. We're going to work on working directory, installing packages, and then we are going to do something very true about ggplot2. Okay. Now, number one, we said create a folder somewhere in your computer, anywhere. But for me, I created it here in my desktop. In that folder, call that folder RStudio. Then afterwards, I want you to put the data that I sent in the group in that folder. All right? Higher. Okay, now we are done at that point. Next, go to R. This is our R. I told you we had 4 interfaces, but now we have 3 here. But I want to show you first how to install packages. When you come to this, the last interface here, I don't know what we can call it here. When you come here, you'll find that there are files, plots, packages, help, and viewer. I want you just go to packages. See, these are packages. Then you go to the option of install. Click install. It brings you this dialog box. Then write the package that you want to install. We started with the GG. We said ggplot2. Then you say install. I told you I'm not going to install mine because I already have installed it. Okay, second thing is say install. You click install, then it installs. I already have it, you cannot install. Another package I wanted you to download is a package called SKIM-R. SKIM, S-K-I-M. I installed it. You could see that I installed it. I cannot install it twice, unless there's an update. Another package that you want to download is the readr package. This readr package. So that readr package, I installed it. You don't need to install again. Now, after those packages have installed, I told you to come. No, another thing I didn't tell you. I told you to come to this far right corner here, where mine is written RStudio because that is a working directory that we created. But I want you to click there and then click new project. Let me say, don't save that one. Now it brings us this dialog box. And then I said you go to existing directory because we created that folder there. So go here, browse, go to where that folder is. That folder is this one. Then say, click it and then say open. Then create project. So then we have created our working directory to be that place. A working directory is an environment or a folder whereby we have everything that we need and everything together there. Now we have installed packages, we have created our working directory. Now I want us to create our first interface, which I told you to come to this corner. You see there's a document and a plus here, click that one, then pick the first option, which is create an R script. After that, I told you now, we downloaded the packages and put them in our computers. Now we want to take those packages and use them in our R environment. And I told you it's like in a bookshop where you have in a library where you have to take a book out of the shelf and use it. And with that, we use a command. We say library. Library. The moment you start writing, it suggests to you it knows what you want. So then you write the name of that package. Every time you write that command, it gives you the options that you're supposed to do in that command. But for now, ignore those ones. I want us to take in ggplot2. We install ggplot2. I want us to load packages. This is called loading of packages. ggplot2. Then you run it. Another package we downloaded is SKIM-R package. Load it. Another package, library, is readr. That's the other package that we downloaded. Now we have loaded them. They are ready for use in our R environment in our computer. You might find some differences in your interface and mine. I made some adjustments. You might find that your console, instead of being at this point, it is down here, and then the environment is up here. I interchanged it because I think for me, it is easier for me to look what is happening on the other side than just looking down. So it is better for me this way. Those are things I'll show you how to change if need be. Now you have loaded our 3 packages. Now, I want us to import our data. That's where we were. Come to files. We said here we have several things. We have files, plots, packages, help, and viewer. These are things we'll go through. We go to files. Files, you remember we copied our data at that working directory that you created, that folder I created on the desktop. You just come here and click that data once, and then you select the import dataset option. Now it brings you your data. This is how our data is. That's how it looks like. Everything is there. Now, if you look at this corner here, you have the name. You can change the name. Let's call it data frame, DF for data frame. No, don't come here and say import. That's not a good option. Go to this clipboard here, written clipboard, and click it. What it does is that it copies this command. Okay. Then after that, cancel that. Come to your console. This is where you said you write your code and paste it there. Okay. First of all, it brought you the readr, the library readr package that we installed. You say you run that one, then you run also the one that it didn't change its name. It's okay. It's physical chemical parameters. It's okay. After you say that data has already been imported into R, and you can view that data using the view command, view physical chemical parameter. Now, we have viewed that data. This is how it looks. This is the data that we have just imported. Now it is in R, ready for analysis. Now there's some things I want us to look here into this package. This is written physical chemical. This physical chemical, it is the name of our data set. And this is a command that has brought the data into R. You can see here, this is read CSV. Read, I don't know what you call it. This is not a hyphen. I don't know what you call it. CSV, then into brackets, the name of that data, physiochemical.csv, meaning that even this code, you could have written it. Instead of having it that way, you could, instead of loading it that way, but that is the best way to do it, the easier way to do it, you could write this code and you also do the same. You import that data into your R environment. And then and view physical chemical, it brings you the view of that data in here. The data now is in R. I hope that is clear. I hope it is not complicated. I hope that is clear to everybody.
Yeah, I'm following.
Okay. I hope yeah, we are together. Now, there's this command here. This sign here. This one is equivalent to is equals to. So this is equals to, the way you say 1 plus 1 is equals to 2, is telling us this physical chemical parameter is this equivalent of saying is equals to. You can even put an is equals to sign here and it works the same way. But because is equals to sign has other functions in R, we use this sign here. This one, I don't know, it's the sign for less than and a hyphen. No, you don't, there's a shortcut to write this function or this sign. You click control, not control but alt. You see the alt key in your keyboard, alt key keyboard, and the hyphen and the key that has hyphen, the key that has hyphen in your keyboard, the one that is before plus. If you click them, you press and hold alt and the hyphen button, it gives you that command. So these are some of the shortcuts I'll be showing you as we go on. So that's how. So meaning that what I mean is I could write this code the same in a different way, and it will just import that data because that data is here. You can see our data is here in our environment. It is here. So I could write a code and say my data frame. I've said alt and the hyphen key. Then I say read these I don't know what they call it, this slash that is not slash, it's not hyphen, I don't know what they call it. shift of that. Even it gives you those options. It brings those options there. Then you can say enter, it puts into brackets. Then from there, you write the name of that data. Our data is physiochemical.csv. You just write it as it is, but you have to put it into brackets. Not brackets, but into quotation marks. Into quotation marks. Then you write it inside the quotation marks. Physio, it is physio, is a hyphen, chemical, dot, CSV. Then you run. We have imported that data again. That's how so you could use the first method, you can use the second method where you write your code itself. You have imported that data into R. And you can view that data using the view command. This is what I mean, you write view. And the moment you start writing, it brings you that option. So just say enter and write that data. Our data is DF. And then you run it. It shows you that data. You see, this data is the same as the one it is the same data we have imported into R. Now we have imported our data into R. Steve is not here, but he was asking whether R can give you descriptive statistics. You want to have an overview of how your data looks like. You use a simple command called summary. If you say summary, then the moment you start writing summary, R already suggests for you that's what you want. You say yes, summary of my DF. You say, and you run it. This is our DF, and run it. If you come here, it gives you the summary of your data in terms of like the station. We have our first column here is of a station. It is telling us in my station, the minimum of the station is 1. The maximum is 4 because you have this person had 4 stations, the first up to the 4th one. And it is giving you the first quartile, the median, and the mean, and the third quartile. But that is not important as of now. You can go look something like temperature here. This is temperature here, temperature here. The minimum temperature here was 25.6. This must have been degrees Celsius. The first quartile, though you understand the first quartile is 25.88 degrees Celsius, and the maximum temperature was 27, and the mean and the median. So it gives you an overview of how your data looks like or how it is. Something else you remember, we installed a package called Scheme R. So we can use that Scheme R package to skim through the data, to skim through the data, to go through the data and see how it looks like and whether they are missing values and such thing. So you write just the word scheme. Scheme, you see, it suggests for you, scheme, then you write your data. Your data is DF. You see, this is what it does. It gives you a summary of your data. For example, now it gives us the variable. The variable is everything that is in the column. Every column is a variable and every row is an observation. We'll get into that. So, station, is there any missing values? No. Is it complete? Yes, you see it is 1, 1. What is the mean? The standard deviation, and then the quartiles as the year. And then here finally, although this is not very clear, it shows you a histogram of the distribution of that data. So that is scheme DF. I think with that is enough for summary. Now, looking at this data, you can see these are our stations. This is the latitude, the longitude, the position where the data was taken, the month that the data was taken, and the data here is transparency, depth, temperature, dissolved oxygen, and all that. We would like to know the distribution. We would like to know how this data we like to visualize maybe the temperature, see how the temperature varied with the months, or the dissolved oxygen over the months, the depth and everything, the conductivity over the months. Now, I introduced to you, we downloaded a package called ggplot2. This ggplot2 means the grammar of graphics. This is a graph. When you go, every language, whether it be French or English or whatever, it has its grammar. When you construct a sentence, then you are told that that sentence is grammatically wrong. The same here, we have a grammar of graphics. How the grammar, the way you're supposed to order, or the way you're supposed to arrange your the order of your visualization for it to come out the way you want it. So this is called the grammar of graphics. GG means grammar of graphics plots. That's what it means. GG plot 2, grammar of graphics plots. Now, the grammar of graphics plot takes a very simple, this is the backbone of visualization in R. This is very important. This is what everybody uses, and I want you to get this. So if you want to visualize anything, number one, you write GG plot. It actually brings you there, GG plot, enter. The first thing that you put under that, the first thing that you put there is the data that you're using, the data. Our data here, it give you the data is equals to, our data is DF. You put, it's called whatever, a comma. The next thing is mapping. How do you want to map it? How do you want it? What do you want to be in the x-axis, and what do you want to be on the y-axis? That's what simply it means. So mapping is equals to IES. This IES means aesthetics. Aesthetics, how you want to put your x and y. So our x, we want to visualize maybe temperature over the month. So in our x-axis, we want our x-axis to be is equals to the month. The one that is below it is the month, the independent variable, comma. Then you write y. Y is our value, which is now is the temperature, the dependent variable, which is the temperature, and it is written, just write it as it is, temperature. Now that we have written, that's how we want our plot to be visualized. If you run this, just run this, it gives you something like this, but there's nothing that is plotted. You see, our temperature is here, our months are here, but these months are not arranged according to which first starts and which month is before the other. It has just arranged them in grammatical, whatever, alphabetical order. But now there's a way we can do it and put it in the order that is supposed to be. After that, we want now to plot here. Maybe in this environment, we want to plot either bar graphs or line graphs or points. So how do you do that? You come here and say plus. You get out of the brackets, and write plus. Now after plus, you write geom. This geom means geometry. Geometry is a shape, a geometry. Geometry is a shape. Which shape do you want to use? And for me, I want to use columns. Columns, what you call the bar charts. I want to use a column. Geo column. Geom col. Geo col. Okay? I've written that. So if you run that, you can see what it does. It has brought to me the temperatures, the bar charts of temperature over those months. You can see there was not much difference in temperature over the months. Then this color might not be so good or appealing to you. Inside these bar graphs, the columns that you have created, you would like to have them maybe a different color. You say fill those bar graphs with is equals to which color? Let's put this one down here. Which color would you like to be? You put that color into brackets. Not into brackets, but into quotation marks. You can write any color that you want. Maybe orange. Let me see. But they're not, orange is not a very good color, I see. You can write another color like maroon. Gives you maroon. Maroon is not a bad color. I don't know colors, but it's not a bad color. You can write something like purple. Gives you the color that you want. Now we have created a bar graph. No, you see, we have written here data is equals to DF, mapping is equals to aesthetics, X is equals to this and that. But you can drop all these arguments that look similar, that are not necessary. So you can write GG plot. What is Isaac saying? So instead of saying data is equals to what, you just write your data, DF. That's our data into brackets, not into brackets, but comma. Then instead of saying mapping is equals to, you just say aesthetics, IES, and it gives you there. You click that one. Instead of saying X is what and Y is what, it knows what it will be. Isaac should need some helping. some help over there. So somebody talk to him. Okay.
Dan?
Yes?
You can mute him because you are the host.
All right.
Yes,
All right. Let me see my participants. I think I'll mute him. I think I cannot see him. I think he's out. Anyway, let's go on. So DF, so our X is month and our Y was temperature. Simple as that. Then come here and say plus the geom. No, this time we can use something else. We can use points. Maybe let's say points. Say geom point. We have something like a scatter plot. Geom point. Everything is there. Point. Then you just click it. It gives you the points where everything was. And this first part does not change. What changes is the geom, the shape that you want to that you want to use. So even I can copy this one here, copy, and paste it down here and add another geom and say I want something. I want points, but points that are all over jittering all over. So say geom jitter. See, these now are the points, and you can whatever color you want them to be. Say color is equals to put that into quotation marks and say maybe orange red. Orange red is orange red. Let me see. Run that. That's the color there. You can try any color that you know, sky blue, the color that you want them to be. The good thing about R, you can customize your plots the way you want them. Now we have showed you the geom point, geom jitter, geom column. There are so many geoms. There are so many ways in which you can show your data. There is a box plot, ggplot. Let's write a box plot, ggplot2. Our data is DF. Our aesthetics. Let's put our month there. Then comma, then our temperature, plus geom. I want us to put a box plot, geom box plot. I want to show you how geom box plots look like. Box plots. See, these are box plots. These are what are called. If you've ever seen these ones, these are box plots. You can, it's called notch. Notch is equals to true. Just a minute, don't worry about that. Just give them some shapes the way you would want it to be. But that is this now. You should know, you should catch this, you should get this now, because this is the backbone of visualization in R, ggplot2. So you can have a geom of geom line, all this geom AB line, this I think is a straight line, geom area, geom density, and everything. Geom bar is error bars, all this, all of these shapes. You're going to go them through one by one, and you'll have to you'll understand them. So don't be worried about them. So I didn't want to tire you with a lot of information. I wanted us to just cover that. That's what I prepared to cover with you. We can go further, but I don't want to do that. I want you first to go and explore what this ggplot2 can do for you. And I think I'm done.
Thank you, Dan, for that presentation.
You're welcome.
I've been following actually, though I was lagged behind a little bit, but I'm going to replay this so that I can be at bar with you guys.
Okay.
Yeah.
All right. I hope it was helpful. I hope you've learned something all the same.
Yeah, it was very helpful. The problem was when I was installing the packages, there was a warning that was coming that it's R tools is required to build R packages.
Oh, okay. You would have said just ignore that one.
Oh.
You would have told it to ignore, and then it will continue to install. I didn't want us to install R tools before because it has some process, but maybe you can install it next time, or maybe you can have a day during the week where we can install R tools together.
But at least I was able to maneuver until I downloaded the 3 packages.
Okay.
Thank you. I'm grateful.
Okay. So I hope you've learned something.
So much.
Okay. Thank you. Anybody else?
Hello, Dan.
Yes.
Yes, the meeting has been awesome. We have really learned a lot.
Okay.
So it means, because I've seen there's a difference when you come to write these, I can say, is it a package for geom? Is it column? And then you write fill is equals purple.
Yeah, any color you want. Yeah.
And then when you come to write for geom jitter, I saw that you never wrote fill.
Oh, it's not a must because
meaning it is not important. It is not necessary for you to write the fill.
Yeah. But you can write it the way you whatever color. Oh, I wrote fill instead of color. Oh, sorry. I'm not sorry. No, in the bar plots we call it fill because it is that we are filling in that bar, in that column. But when it comes to points, we color them. We give them
Yes.
color. Yes.
Okay.
Okay. Those are some of the
it's okay. That is where I just got confused.
Okay. Anybody else?
Thank you, Dan.
You're welcome.
I've learned also enough. And then me, I'm waiting for the Regis video to try it again.
Oh, the recorded video.
Because it was so quickly.
Oh, I'm sorry. I'm used to being quick.
Okay.
Okay, I will share the video. No problem.
D'accord.
Yeah, but I hope you've learned something you followed anyway.
Yes, I've tried to put all the package.
Okay.
And try to have my file.
Okay.
To view.
Okay.
And summary.
Okay.
Yes. But I did not finish to deploy those things like you.
Okay. I'll give you the video, then you'll get it, and then if you have any question, you can ask through WhatsApp or anywhere. You can ask me. Then I'm free to answer you anything you would like to know.
Okay, merci.
Okay. Have the rest of the guys disappeared? Are we together really?
Yeah, we are.
Okay. So I think that was it for me.
Done.
Yes.
The meeting was good. I have learned something new today. I didn't know about the scheme thing. And it has been really, it was good because I didn't know, like, if you scheme, you can also like see the histograms inside.
Yes.
So that was something new that I learned today, and also like the filling in the columns and the coloring of the jitters.
Okay.
It was good.
All right. No,
Thank you.
You're welcome. I think now we can end the meeting, and then I can upload the video later. Thank you so much for joining.
Thank you. Bye. Good night.
Everybody have a good night.
Bye bye.
Good night.
Good night.
Bye.
Itakuwa lecture.